Hi everyone, and welcome back to this series of videos of coding in Dogen. So it's just to recap, we've had a few days break, and in those days I've done quite a bit of work, but sadly I've been doing work and doing my commute and the train and so on, so it wasn't very easy to try to record in those days. What I'll do now is I'll try to do a quick update of where we are now with all those changes. So about 6 days ago or so, when we recorded the last video, we were struggling to generate, to get ODB to generate the code. And so if I have a quick look at the log here, just travel in time. So we could get Dogen to generate the code, but then when we ran ODB was getting very upset. The reason for that is that we actually found a bug. So I'll just jump over to Agile. We actually found a bug in Dogen, and the bug is captured in one of these stories. Yes, so schema name in ORM should be transitive. So we kind of found two bugs really. These two guys here. So the first bug is that if you do not set some ODB pragma, particularly at either the type level or the package level, then we just don't bother to actually generate the code that tells ODB that it needs to do something for this type, but they just the ODB pragmas don't get correctly generated when there is no pragma at all. As it happens, almost in every case, if I take as an example our test model, and this is one of the problems with tests, is that sometimes you test one thing, but then in reality you end up using things slightly differently. So the reason why I never noticed this problem is because, of course, almost every other model in the world would always have a schema name set, and schema name would then trigger the ODB pragmas to get generated because we need to tell ODB about the schema. Now, we did have schema name, you probably will say. We did have a schema name set. The difference is the schema name was set at the top level in the model, and then we created a namespace called tracing. So it made it slightly different from this model, where we don't have a namespace. So what Dogen was doing is to look up at the containing namespace and say, oh yeah, there's a schema name for this, and it would just use that. In this particular case, Dogen was trying to do the same thing, which is to look at the containing namespace, but there was no schema name set at this level, and because there was no need to, there was no manually set ODB properties either, then we just didn't generate the required ODB pragmas for ODB to know what to do with the type. So now, this is why we have two bugs here. The first one is that perhaps the schema name should be transitive. So in other words, when you're creating a model, if you set the schema name at the top level, you probably should just inherit that across all the packages. I still haven't quite made up my mind on this. The thing is, schemas and namespaces are not quite the same thing. They're similar concepts, but not the same. This is the usual impedance mismatch between relational model and the object-oriented model. So in the object-oriented world, we use namespaces to package things, really, and sort of related types all go in a similar namespace or in the same namespace. In the database, schema names are not quite used in the same way. We tend to use them at a more coarse-grained level. So for instance, if you had a schema for Dogen, you wouldn't have necessarily sub-schemas, because there is no such thing as a sub-schema. So you're not going to end up with a database for Dogen with lots and lots of different schemas for each of these namespaces, or at least that's not a very typical thing to do. The reason why is because it becomes a bit cumbersome to do references across schemas. So most people tend to use, for a given product, they tend to use one schema, and then just make calls across that schema. And then sometimes we use hacks, I guess, such as having a common prefix for table names and trigger names and proc names and so on. So for example, tracing underscore, run ID, and so forth. So it doesn't really map neatly the idea of a schema name over to a relational model. So this is the first problem we had. So we just, as usual, we just decided to solve the problem the quick way, which is just to set the schema name again inside of the namespace. That then triggered all of our code generation stuff to kick in. So if we go back to Git and look at the history of the last few days, you would see here somewhere backlog grooming, generate latest model, if I'm not mistaken. This is still part of the work we did for the previous video, and you just keep going up. At some point here we are. So at some point here we decided to add the schema name to tracing, right? So that solved that problem. So at that point the ODB then was happy enough to generate all the ODB files. And so we generated all the ODB files. At this point we're kind of happy that all the stuff that we had in the model, which is this guy here, was being generated correctly by Dogen, and ODB was picking it up correctly and was generating this code. So we generated all of that, and we then moved over to try to integrate the relational model with the rest of the ODB code base. And for that we just added a number of options. So if I jump over to what we call the API model, top level model, and the API model, we just define the API to Dogen, and in here part of the API is the configuration of Dogen. So we went away and we created a few new options, such as the database configuration, and we created a tracing backend, and we added that to the tracing configuration. And for good measure we then decided that it probably was a good idea to also add support for SQLite. So if you go to the relational model, you see now that not just Postgres, the database system we're targeting is not just Postgres, it's also SQLite. The reason being is that it is likely sometimes that you're going to be in a machine somewhere, and you may not have access to Postgres, but you may have access to SQLite. SQLite is just a binary, you can get it from almost anywhere. And if you're trying to debug something in someone else's machine, whilst you're not going to have the full power of Postgres, like for example you're not going to have access to the store procedures and so on, at least you have some kind of way of dumping the data into a relational database. And if that's still not possible, then of course you can always go back to tracing with a file. So we then of course generated all the ORM so ODB code for SQLite, a few tidy ups, and then of course we added support to the command line parsing for these new options. So if I just close this for a second, and that guy too, and if we just return here to master and just leave this in a nice tidy this workspace in a nice tidy way, we just leave the process here, because it's always good to see what my Git's thinking is doing. So if I just jump over to a Dogen shell and let's just clean things up a little bit here. So if I just go over, oh sorry, and if I just run the Dogen CLI with minus help, now you see this is part of the work we done last week. Not a good idea to randomly press keys in Emacs. You can see that we now have the database options. Now these of course are not plugged in, so you can supply these options but nothing will happen. It just does some kind of minor validation. So for example, if you do database port and it's not an integer, Dogen will pick that up and get upset about it. So some minor stuff is in here. We still need to hook everything in and actually try to connect to a database, which is what we're going to be trying to do in these next couple of videos. But however, one thing I'd like to highlight is the messy state of our build at present. So we're in a bit of sort of a rough spot at the moment in terms of builds. Whilst our Linux build is passing, as you can see here, the only reason why it's passing is because we comment out, or we've ignored both the OS X build and the GCC build. And these are failing for different reasons. So the GCC build is failing because we're just basically taking too long. It's just we haven't got enough time to build the GCC. The compiler is too slow. the OSX build is failing because actually that's interesting. Let's have a quick look at why the OSX build is failing. I think it's because it's trying to link ODB and is failing because we have a different version of ODB in our VC package build. So if I just scroll up here, try to get some be nice to actually just see what the error is. Yeah, no, quite interesting. It's actually it's finishing the entire build. That's a bit surprising. We just have a number test failing. Ah, okay, right. So the relational model tests are failing. Now that's rather interesting actually, because I thought that the relational model wouldn't even build. So clearly we have the right version of ODB in the build, the VC package. So what we can do is to try to understand what's going on here. Well, we can just jump over to C dash, and in C dash our nightlies look very nice, but if we jump over to the previous, yes, so you can see a sea of red at the moment, right? Windows is definitely the worst, but let's just try to understand what's happening in OSX. So yeah, we're having 50 failures. No, okay, right, so this is exactly what I expected to see. So we are basically failing to build a relational model, and the reason why we're basically failing to build a relational model is because the VC package version for OSX has a older version of ODB. And ODB is very careful about that. It doesn't allow you to link unless everything is nice and tidy. So the problem there is that we're going to have to spend some time trying to update the VC package for this operating system. And for Windows, things are probably even worse. We don't even have ODB at the moment on Windows. So both of these environments are a bit screwed up. So what we really want to do in these sort of cases is, I mean, if this application required to have ODB to function, then of course we should just fail if it's not present. But it is still an advantage to be able to use Dogen without building ODB. So really what we should do is we should, for now at least, we should have an option to build Dogen without ODB, without the relational support. So what we'll do is we just quickly go over here. That will allow us to get the build screen again, and it will also allow people to build Dogen without having to install the whole world. We'll just jump over to Agile and say make the view of the relational model conditional. So we should only build a relational model if ODB support is present. Otherwise, we should ignore this model. Dogen should still function, but all code related to the relational model should be excluded. Now this includes the command line options related to the database configuration. In the paragraph here, we should also tell the users that Dogen was built without relational support. This is just so that you know what kind of build you've got. Like, so for example, at the moment, if I And we probably should have started clocking perhaps a few minutes ago. Yeah, this is just so that you so if I hop over to the shell, so at the moment of course you see all these global options, and there's also a version here. So when these options go missing, so for example here, when you don't see the tracing backend and when you don't see the database option, I mean, you're probably going to be wondering, oh, what's wrong with my Dogen version? So we need some kind of way to tell people that, okay, you know, your Dogen just doesn't support this, which will make life much easier, because that means you can still build Dogen with pretty much just Boost and a couple of other libraries like DTL, just to make your life a lot easier. And the biggest problem at the moment is that we're relying on a version of ODB that's actually not released yet. 2.5 is still beta, so you can't even install that from your distribution. You have to wait until the code synthesis guys release that. So this is going to solve our build problems, and try to get a little bit of green here again, because it's impossible to see anything with all this red. The second problem, which is also related to the build problems, is the fact that we're taking too long to build. Now, the reason why we're taking too long to build is because we are generating a large number of tests. That's why there's so many tests here. These tests are generated tests. Now, the problem we've got with this is that we generate these tests to make sure that the code that we generate is working. So these tests are useful. However, we can't afford to have these tests in continuous builds anymore, because as I explained, we are really close to the maximum available time for Dogen in using GCC. So what we need to do is, and I've captured this in a story during the week, is we need to somehow be able to not generate the tests when we're doing typical continuous integration, but generate the tests for things like nightly builds. And in addition to that, we probably also want to start sending coverage information only for nightly builds, because of course our coverage at the moment is based on the continuous build. In fact, I don't really trust coveralls that much. I tend to look at code.conf, maybe because it's higher, I guess, but yeah, as you can see here, due to the generated code, we have not too bad, not too shabby, the coverage really. So that's a good thing. When we remove all these generated tests, our coverage is going to drop a lot. So we need to make sure that we only upload coverage information from the nightly builds, and we only run the generated tests on the nightly builds, because that will give us a true picture of what's being tested in the system. Otherwise, the coverage is going to be jumping up and down all over the place. So that was some of the findings we had during the week. And that's where we are right now. So this video is really just to capture all that work, and let's just make sure we haven't missed anything. So we're gonna quick jump over to Git. Yeah, so we had a look at all these commits. Today, what's our objective then? So our objective is, if you just go back to Agile again, our objective today is to let me just close these stories here, just a better, cleaner view here. Our objective today is to then return back to the work that we're trying to do, addressing the relational model, the integration of the relational model. So I suspect we can just move over to this story now. So the next thing we need to do is to try to connect to the database, really. We're generating all the code, but we're not actually attempting to connect to the database. We've got all the credentials and so forth. So in order to connect to the database, we need to refactor the models a little bit. If we jump over to tracing, which is where all the hard work is going to happen. So as you can see here, the tracing model relies on a template here. This template is IO-able. In other words, can you convert this thing into a string? And in order to, and of course, all the models are IO-able because you get that from the facet IO. And what we've done is, if I jump over to profiles, you can see that pretty much if I look for ODB hash serialization tests, lexical casts, test data templates, somewhere here we should see IO set true. Let's make this a bit bigger. CMake, ODB, hash, serialization, test statement list, test on main, lexical cast, test enable, test data templates, MS build, most peculiar. I don't seem to see. Oh, okay, right. The reason why it's not there is because by default all the facets are on. And so therefore all we need to do is to just disable the ones we don't want. We don't have to bother with enabling ones. So really we could remove lexical cast from there, but it's not that important. So yeah, so IO facet is being generated, so all the types at the moment across all models, you can dump that to a string, and it just works. So tracing is just relying on that at the moment. It's basically saying, well, you must be able to convert this type, whatever that type is, over to a string. Now, what we really want in the future is we want this tracer to deal with multiple tracing backends. So it needs to be able to convert things to strings, but also to convert things to the relational representation, which is this chap here. So we need to take any arbitrary model, pass it to an adapter of some kind, and convert that to this. Then, once we got this, we can then dump this to the database. So the current tracing interface is no longer suitable. Now we have a problem. The tracing interface was designed to be agnostic of the IObles. It doesn't have to know what it is, provided you can convert it to a string. It doesn't have any dependencies on any model. In the future that's no longer possible, because now we need to know about this thing, because we need to somehow convert this over to something else. So I think I have some notes on this. I think the idea now is to just basically say that tracing will depend on anything that's traceable. We didn't really put any notes here. But it seems sensible to me that the tracing model now depends, we have to depend on every model, including the relational model, because once you need to know what arguments are being passed in terms of a start transform and an end transform, then you implicitly have a dependency. I mean, we could only depend on the relational model, but of course when we are trying to dump something to a file as a text, then that wouldn't work with it. So no, we seem to be able to have to depend on every single model that's traceable, anything that we trace, which is not a big problem. It's just sometimes we, as every other nerd, we like to keep dependencies as small as possible. So we need some kind of interface here, really. Something that is going to represent the idea. Oh, I forgot about snapping to grid. This always annoys me, because every time you start opening and closing files, Dia seems to forget settings. So if we had some kind of interface, say tracing backend, and if this interface had something like think about this for a second. We don't necessarily need to know if this is a start or an end of a transform. We just need, well, in fact, let's have a quick look at what the tracer is doing at present. Let's just leave this for the moment. Sorry, I'll just make sure. And of course, because we are in tracing, we don't need to call tracing backend. We can just call it tracing. So let's just save that for a second and park it for a minute. And then if I just have a quick look at what the C++ code does at present. So say I look at I don't know, so trace. We have a tracer.jp. We have a tracer.jp. So you can see here the tracer is in a tracer we start the chain, and then we do the file related operations here. What's happening here is that we are converting the file, the IOable over to a string. It's rather interesting actually. So we have an IOable here. Clearly the user must have included the headers required to make this thing IOable. But we are only supplying a type, so a strong type. Somehow we need to... clearly what's happening here, of course, if we just follow this... should really have a shortcut for this, but... what? That's peculiar. Just restart our workspace, because LSP seems a little bit confused. Very confused, in fact. I'm not entirely sure I can't find this, but clearly it's here. Occasionally LSP just misbehaves, not sure why. So of course, so see what's happening here? We just literally propagated the notion of a template-based interface, and this guy also doesn't care who it is that you're writing, provided that guy is able to convert itself to a string. And that conversion happens at this point because we implement the operator inserter, which is what all the IOable and IO facet gives you. So we're just literally passing this down further. Now this is no longer going to work. So it's no longer possible to take this approach because of course there's two different representations, one of which is not string based. So we need to know of the actual type, and we need to adapt that actual type. So we need to replace all the calls that are taking IOable to something else. The other interesting thing here is that we are managing the path for writing here. So in effect we've conflated two concerns here. One is the idea that we are, the tracer is managing tracing, but that tracing is also managing the file backend. So tracing is also responsible for knowing where to write, what to write, and to write it. Which is, it's okay if you only have one tracing backend, but not ideal if you have more than one. So that's one aspect of it. And then if we have a quick jump to the implementation of this, here we see all the code to handle current directory, handling the path for writing, and we have the start transform. So that's a bookkeeping we need to do in terms of start transform, such as keeping a stack of the transform chains and transforms that we're executing. And we need to push and pop as we start and stop. Now that code all could stay exactly the same. There's not a lot of difference here. So end transform and tracing. And then what we do is when we end tracing, we then actually take all the data we got in memory, all the metrics and so forth, and we dump that over to a file. Now of course we don't necessarily need to care about dumping metrics and other information to a file because we're not being a file-based backend, clearly. Some kind of hackery going on here with operator equals and space shouldn't have been there. Okay, cool. So in conclusion, what do we need to do here? We need some kind of interface. So tracer will have to change to start relying on actual types. Anything that's traceable must be going here. We need to factor out all the work that's going into file related operations. It needs to move over somewhere else, and we need to create two different backends, a file backend and a database backend or relational backend. That seems like, let's just write this down so we don't forget. Let's hop over to Agile. I mean, I always end up pressing F8 and so on, but of course you can just jump directly using the key. This takes a bit less time, but somehow seems to always forget about that. So we need to refactor tracer as follows. create a top level interface for the notion of a backend. Move all the file related codes, create 2 implementations of the backend, file and relational. Move all the file related codes to the file backend, and then update the tracer interface to take actual types rather than templates. Then implement adapters for each model to convert them into relational model types. And finally we need to implement the relational backend. So that seems like a reasonable set of tasks to do. Now let's just make sure we got them in the right order. So I think this probably should be in first. My org mode is misbehaving at the moment. So I need to, every time I do a melp update, something seems to break. So we need to update the interface, the trace interface, to take actual types rather than templates. That seems sensible enough. We need to create a top level interface with the notion of a backend. We need to move all the file related code to the file backend. We need to implement adapters for each model to convert them into relational model types. And we need to implement relational backend. I think this sounds about right. Okay, so let's start with the first task then. We need to implement the tracer interface to actual types instead of templates. So, well, best thing to do is to try to understand. I mean, the problem is because this has been so flexible at the moment, we don't even necessarily know what all the uses of the tracer are. So we are probably tracing a lot of types at present without even noticing. Best way to try to understand the scope of the damage is probably to just jump over to this. Let's just name this area. Let's just call this crap. So if we just jump over to integration projects, and just for a laugh, if we just do a quick grab on start chain, let's just see how bad this is. Well, it's actually not too bad. Just let me have an autosave, so let's just read it autosave. It's actually right, it's quite surprising. The reason why this is extremely surprising is because, of course, we never actually use tracer directly. We have this other interface called scope tracer. Scope tracer is responsible for actually doing the hard work. And so we have 2 implementations: a scope chain tracer and a scope transform tracer. Now I bet you if we were to again, my Emacs seems to not like me at present. So if I jump over to grep now, if I repeat that exact same grep, I suspect it's going to be a bit more dramatic. Yes, slightly more dramatic. So what have we got here then? You can see first we have a lot more uses. And remember, this is only the transform, so we got the same thing for the chains. We probably have. Well, it's actually not too bad, to be honest. It seems largely as expected, just top level models are being dumped. So it probably is just a case of the assets model. The engine model is probably using assets and the other models. The extraction model, the generation model, and the injection model. So there's 4 models. Oh, and of course the variability model. So it's 5 models. Okay, so we're going to do first then is we're just going to jump over to C++ and we're going to add dependency on these models in tracing. So if we take something like, say, engine, engine is a good model because engine sits at the top of our orchestration, so it depends on everything. So variability, tracing, injection, assets, extraction. So if you take this model, and then if we hop over to tracing, and we say, well, the life's about to change slightly. So what we'll do is we'll just, oh, that's actually quite a good order of dependencies, to be honest, and then we just take away tracing because we can't really depend on ourselves. And funnily enough, there's a bad Dogen bug at present. If you do recursive dependency, it causes Dogen to go a bit crazy. So variability, injection, assets, generation, and extraction. So we got all the models that we need. Now, of course, you may remember that we do JSON and dia at the same time. So similar exercise has to be done here. Due to that bad bug that I mentioned before, whereby we can't actually generate the JSON models automatically. So unfortunately we need to do a lot of hand holding of these models, and to be honest, the correct solution for this is going to be in the future to actually, once the conversion is fixed, to actually not even bother to store these JSON models in Git. You can just generate them via conversion and then generate the code. And if it breaks, then you'll see on the nightly as a generated test. So we don't even need to keep track of these models in Dogen. We just don't have enough time to do all these things. Right, so now if you remember, we can't reload things in dia, quite annoyingly. Oops, the imagination relational model, I meant the tracing model. So there we are. That tracing model has dependencies and everything and their dog. Again, don't forget to snap to grid. And as you can see, I forgot about some of the snap to grids and other models. Now, what we'll do is we will start replacing these star chains. One at a time. In fact, to be honest, what I'll do is, just so we can regenerate this model, I'm going to remove that from there. And then what we'll do is, one at a time, we'll start from the top. We're going to replace start chain and end chain with the actual type. Now, in theory, the whole interface should remain constant. What we're going to do is take this away from a template, put all the types we're passing in, and then implement this in the CBB. And nothing should break. And when it breaks, it will tell us there's something we forgot. So that's exactly what you want. Right, so we know that every type that we're putting through this grinder is going to be a model of some kinds. Oh, actually, another thing we want to do as well, this is going to break in a second, might as well fix it now, is to copy across the dependencies. So extraction, injection. We are not going to bother. Actually, that's an interesting question. I wonder if we also need to know about the individual models. Well, you know what? We'll start by not caring about the individual models and see how far that takes us. And then, if that doesn't work, then we go deep. So, tracing. And as you can see, the tracing model is very nice and neat here. Of course, Dogen should be generating all these make files, but it isn't at present, again, because we don't have enough time. Extraction, and of course, we need variability here. Now, I like to keep this in some kind of order, pipeline order. So, first we have variability, then we have injection, then we have assets, then we extract, now then we generate, and then we extract. Right. So now we have all the dependencies. At link time, just for good measure, make sure we still can compile, and we can't. No, that's before we do anything. Let's have a look at Git. Yes, we started messing around, so that's fine. That looks good. That looks good. That looks good. So let's try compiling again, and just so you can see what I see, we'll just jump over to the compilation buffer. And, a bit of a big build here because of that touching of that scope tracer, but I don't think anything special is going to happen here. We'll just let compilation do its thing. Now this video will finish in about 20 minutes, regardless of where we are, because I need to have a break for food, but we'll continue after that. Right, the build's finished, and for good measure, as we always should. I'm going to give it a quick run of the tests. Nothing should break. Oh, and interestingly, something did break. Okay, let me just show you what I'm seeing. Okay. Oh, this is very interesting. So we seem to be, by adding these models, we seem to have broken how registration is working. It's rather peculiar. Now let's see if this is just something specific to JSON or to... Clearly we must have done a mistake when we included those models. What are the tests that are failing? Yeah, it's both Dia and JSON is failing. Now, what probably is happening here is we created a cycle. This is a bit of a problem. We created a cycle now, of course. It's a bit silly. So now let's just think about this for a second. Let's take the variability model. See, this is an interesting thing as well. We should probably write this down. Before we write it down, let's have a quick look. Let's make sure we don't have it yet. Nothing on cycles. Recursive structures with test scratches, but I think this means just types. So, so creating reference cycles produces strange errors. Now we just capture it like that because we're not 100% sure this is the case, but let's just explain my theory. So we take the variability model, which is here. Now you'll see the variability model, of course, includes tracing. It has to include tracing because it needs it for tracing. However, now the tracing model also includes a variability model. So this is not a good thing. This is really not a good thing. So when we try to resolve this, it's probably going to result in some kind of infinite loop or something. I mean, it's coming out as this really weird more than one master segment found. But I think that's just basically an artifact of the problem. So the way we'll check that is to do something really simple, which is we will just jump over to CMake, and we will just actually not the CMake, but the main CMake. We will just enable logging, and then I'm just actually going to do something like generate Dogen dot variability. Dia. Now, okay, that failed exactly with the same error. Now what we'll do is we will now grab namespace. Or else I wonder if we have a log. Ah, we do have a log. Excellent. So just jump over here to logs, and in logs we have byproducts. So if we have a quick look, in fact this is probably going to be bin, isn't it? Log. Nope. Keep forgetting where I put the logs. So in Clang 9 release, there's no reference here. Ah, the reason why of course is because you're looking at the wrong project. So if we go to Dogen, integration, projects. No, of course not. Doc. Build. And have a quick look at my output. In release. We just need to see. I have my son causing trouble here in the background. So if we just have a quick look at perhaps the log directory. These are showing me the tests. Oh, okay, now we got the byproducts directory as expected. Now, okay, with a bit of luck now, we should be able to find what we're looking for. First, let's make sure this is recent. So today is not. Ah, here we are. 1st of November. That looks better. Right. So this created a log file. Now, what I expect to see here is I expect to see the pipeline. So again, now you can see why I'm reading the log file is not ideal, because it's not very, because it's linear. It's not very easy to figure out what the coordinator is doing. First, let's just get a full screen for this. Makes reading a little bit easier, and then. Now we have to try to understand. See a lot of adaptation code going on here. This is all perfectly normal. I'm probably just looking for something like references. Actually, by sheer luck, this may even work. Let's just have a quick look at how the reference processing code is working at present. This is sadly one of the disadvantages of working in this kind of research projects, is that you start off with a simple problem, and then before you know it, you've got lots of other problems. So we probably in injection, I guess. Injection is probably attempting to load, and it's going to produce a model set, right? So let's have a quick look at this model production chain. So we transform into an external representation, process configuration, breathe input, taking space, and you apply. So okay, this looks like we're just processing a single model. Somebody here must be reading. Ah, here we are, references resolver. So when we read a model, we need to resolve all the references, and that then must generate a set of things that we can extract. So presumably this references resolver, this chap here, is doing all the hard work here in some kind of recursive fashion. Right, okay, so this is good. So first let's just make sure that we don't have any mention of the word cycles here. So now we know what we're looking for. The log file becomes a little bit more useful because now we can say, okay, show me what the references resolver is seeing. That's in our shell command line output buffer. Now I just change this to log view so you can see this as a log file. So as you can see, the reference resolver is looking for extensions .json. It's got a set of directories to look for. It's trying to find the reference. Now what we're looking for is some kind of weird pattern. It seems to me that all that's happening is that we're loading the same model twice, and that's what's causing the... Okay, so yeah, this is what's happening really. We're loading the same model twice, one from one side of the cycle and another one from the other side of the cycle. And then, because we're processing those models twice, when we add that, we end up with duplicate types. I mean, this is why it's manifesting itself as... and we are in the wrong project as well, which you really have Dogen logs, but there you go. This is why it's manifesting itself, as we can see here, more than one master segment found, because it's loading it from two different sides. Okay, cool. Now this now makes perfect sense. I'm just gonna undo, take us back to this. It's getting a little bit crazy here. Right, let's just leave it like this, and then now I'll resume. Okay, cool. So what we'll do then is we will just write this down as creating cycles. No, if a model references model A references another model B, and model B also references model A, Dogen does not detect the cycle. Now, let's think about this. Is there a problem if a model is recursively referencing? Well, from the Dogen perspective, it probably isn't a problem because Dogen could actually get away with it. What is a problem is that in C++ code, you probably don't want that to happen, do you? So, what we say here is this results in the not very obvious error of having duplicate types. What we should do instead is to detect the cycle when loading the models and provide a sensible error message to the user. Okay, cool. So now we know the cycle is a problem. You might have to trust me if you're not convinced, but I am very convinced. Now that we know the cycle is the problem, we need to figure out how to break the cycle. I mean, it's, so what we're trying to do now is to say, well, actually, do you know what? You can't have this dependency. We need to have this somewhere else. Now, one way of doing this is to say, perhaps some higher level model is responsible for a tracing backend. Well, we have to do a bit of thinking here now, I think. Okay, so what we'll do is, because it's going to require more thinking than the 5 minutes that we've got left, we just break now, and to summarize, what we tried to do today is we tried to start implementing the tracing backends, but the tracing model, which used to sit very, very close to the top of our model dependency graph, suddenly was flipped to the bottom. By being flipped to the bottom, it resulted that we created a cycle in dependencies, and that's not going to work. So what we need to do instead is we will take away these very clever ideas that we had here. I think we'll only change that really. Just have to make sure we close the tracing model. Leave everything in a good state so that when we start again, we start from a clean slate. And we don't really want to continue debugging, it just makes model generation slower. And if we just clock the time we took. Okay, so this is all for this session, and we will resume trying to solve this problem of cycles. This is a fundamental design problem, so we just need a little bit of thinking. Okay, and that's all for this session. Thanks very much for watching.